Hey boys and girls, meteorologist Steve Caparata back with Cap's Corner Summer Camp, our final episode of the summer. Now you know what that means. School's about to start back up, but hopefully you're ready for school. Hopefully you've learned a little bit here if you've been with me for Cap's Corner through the summer. I thought to wrap it up, we do something that I think is kind of fun. One of the things I love to do is go outside and just look up at the sky up above every day just to see what I can find. So today we're going to talk about some of the things we could spot in the sky, like rainbows, like things called sundogs. If you haven't heard those, I'm going to tell you about them. The Aurora, which is what we see in this animation behind me, and much more. So let's check it out. Let's talk about rainbows first. These are some of the easier things to see, but still pretty cool when you get to catch one. Pretty shot of a rainbow over St. John the Evangelist Church here in Plaquemine that was captured just a few years ago. So how do we see a rainbow? What is needed for us to actually see a rainbow? Well, there's a few key things. Number one, you need to be located between the sun and some rain. And more specifically, we'll talk about this, the sun needs to be at your back and the rain in front of you, okay? That's rule number one with a rainbow. Second thing you need to know is that the sun's got to be kind of low in the sky, low on the horizon. Now, for anybody that's a little bit older watching this, the angle between the ground and how far above the horizon the sun is has to be less than 42 degrees, so closer to sunrise and sunset in order to be able to see a rainbow. Again, the rainbow will be opposite of the sun, so that means that the sun needs to be behind you and some rain out ahead of you. And then finally, one thing that can help our rainbows appear more vivid is if we have bigger raindrops falling out of our shower or out of our storm. So real simple. That's the important stuff to know about a rainbow. Sun behind you, rain in front of you, and generally around sunrise or sunset, sun's got to be low in the sky. Something else we can sometimes spot in the sky. Now this is a more dramatic example, but you see these spots on either side of the sun. Here's the sun, and you've got some bright spots on either side of it. These are what we call sundogs. So let's talk a little bit about how sundogs actually develop. Sundogs develop when we have ice crystals up in the sky. Now, if you're with me earlier in the summer, I talked about how some of our clouds are actually made up of ice crystals, and specifically, do you remember what they were called? Cirrus clouds. So these are typically when we have some cirrus clouds around that are made up of ice crystals. Now in this specific case, we're talking about hexagonal ice crystals. Mr. Steve, that's a really big word. What does that mean? Well, a hexagon has how many sides to it? 6, right? So we're talking about ice crystals that have 6 sides to them. So as the sunlight passes through these ice crystals, it gets refracted. Refracted means it gets bent, and it gets bent at a 22-degree angle. And once that happens, we get a bit of an optical illusion with our eyes, and we can see these spots on either side of the sun. Now, what will often happen is, depending on where you are, there might be trees and buildings kind of blocking part of your view. So a lot of times it's easier to see one of the sundogs than both, but typically if you've got a good clear view and conditions are right, you should be able to see them on either side of the sun. Now something that's kind of similar to that we can sometimes spot is this, and this is a pretty dramatic example that was captured a couple of years ago locally by Karen Pittman Messenger here. But this is a solar halo, a halo around the sun, or sometimes called a 22-degree halo. So remember, with the sundogs, we were just talking about that light being bent 22 degrees. So it's kind of the same thing here. Can you see kind of the milky shading? Those are those cirrus clouds way up high in the sky, made up of ice crystals, and they are bending or refracting that sunlight and giving us this ring around the sun. Now we can get the same effect around the moon. This is a really pretty shot. I think this one, it was from NASA. I think it might have been up in Sweden, but this is the moon. So this one is called a lunar halo. But the same principle here. We've got those cirrus clouds up in the sky, and at nighttime especially, might be a little bit harder to see those cirrus clouds up above because they're real thin. but they are there. If you see a halo like this, you can bet there are some of those high, thin cirrus clouds up above us. They are bending the moonlight, or the light being reflected off of the moon in this case, and making a halo around the moon. All right, let's talk about something else that we can sometimes see when there's rain around. There's a word we use in meteorology called Virga. So what is Virga? All right, well, let's talk about what we typically see most often. We get a shower, we get a storm. From that, we get precipitation. In our part of the world, most often we're talking about rainfall that makes its way from the cloud down to the ground. But sometimes, if the atmosphere is a little more moist at cloud level and there's some dry air between the cloud and the ground, that rain that is falling from the cloud will evaporate as it hits that dry air and won't make it all the way down to the ground. We can often actually see this with our eyes if we're paying close attention. This is why I love to step outside and just take a look around and see what I can spot. There's so many things you can see if you actually take a moment. So here is a real-world example of Virga. This picture was taken in New Orleans back in 2018, but can you see it? So this is where we've got some rain falling from the bottom of the cloud, but notice how you don't see anything down here. So the air closer to the ground was drier on this particular day, so as this rain's falling down, it evaporates and we no longer have it. Doesn't make it all the way down to the ground. You can actually see this Virga more often than you probably expect. So keep an eye out for that in the days and weeks ahead. All right, at the beginning, I had a neat movie showing the Aurora behind me. You might have heard of the Aurora Borealis, the northern lights. There's also the Aurora Australis, the southern lights. But how do we get those aurora? Well, around the Earth, whether you knew this or not, there is a magnetic field. Okay, that's what these blue lines are showing. There's a bit of a magnetic field that surrounds Earth. The sun can at times be more active. We get these sunspots, we get these solar storms. There's a solar wind that is emitted from the sun, and with that comes some charged protons, some charged electrons that come off the sun. Now, as you boys and girls get into some of your science classes at school, you'll start to, if you haven't yet, you'll talk more about protons and electrons. But as those protons and electrons travel along the solar wind, they start to encounter this magnetic field that surrounds the Earth. And so they kind of get deflected around that magnetic field. But there are some weak spots in the magnetic field, specifically around the poles, the North Pole and the South Pole. So some of those protons and electrons are able to kind of slip on through. And then what they do, if they're able to make it into Earth's atmosphere, we start to get some of that, what you see right there. Now, the different colors are driven by the different interactions with different gases in our atmosphere. So what we most often see is a green aurora, and those are those protons and electrons typically interacting with oxygen molecules 100 to 200 kilometers up above us. We talk more about miles than we do kilometers here in the United States. So you're talking something like 60 to 120 miles up. That's most common. If you get lower in the atmosphere, we've got some nitrogen. It can be more pink in color. You go higher up, you can also hit some nitrogen and get blue. And if you get very high up in the atmosphere, the interactions, you can get a red aurora. Now, remember what I showed you earlier on the graphic. Where are the weak spots in that magnetic field? Closer to the poles. So where we are in Louisiana, we are well removed from the North Pole or the South Pole, right? That's far away from us. So aurora, unfortunately for us, if you want to see it, rarely, if ever, happen this far south. You have to travel a bit farther north to be able to spot them. There are some writings and historical records that indicate that maybe there were some aurora spotted as far south as Louisiana. I think it was back in the 1800s, but extremely rare for sure. Much more common the farther north you get in the northern hemisphere, because that's where we have that weakness in the magnetic field around the Earth. So here's a beautiful example of it, a picture from NASA, and you see how this is mostly green, and that's the most common color that we typically see with the aurora. Now, let me show you what is a really cool video. This is taken from on board the International Space Station. They were flying overhead as we had some really active aurora. How cool is that, boys and girls? Can you imagine being out in space on the International Space Station and being able to see something like that? Pretty amazing when you think about it. A really cool video. All right, one last thing I wanted to show you before we wrap up today. Most of what I showed you are just things to look for, really cool things. We also have what we sometimes call weather folklore, and these are little sayings that apply to the weather that might tell us something about how the weather is going to behave. They've been typically what we call weather folklore has been around for, in some cases, hundreds of years. Some weather folklore is true, sometimes it's not so true. But here's a good one, probably the one that, a saying that is maybe most often heard about weather. Red skies at night, sailors delight. Red skies at morning, sailors take warning. So here's an example of red skies at night. A pretty red sunset over False River near us, just northwest of Baton Rouge. This is from Max Soulier, who has a really, does some really neat video with a drone. But a beautiful red sunset. So let's talk about, does that saying hold true? Red skies at night, sailors delight. What do we mean by this? Sailors delight. Well, you know, sailors hundreds of years ago, they didn't have radar, they didn't have weather apps, they didn't have smartphones, they didn't have ways to track the weather like we do in the year 2022. One of the things they looked for, though, were signs like this. If they saw kind of a red sunset, they believed that the weather was going to be nice in the days ahead and working in their favor. So that's where the saying comes from. So let's talk about how this works and why this saying might actually kind of work out. Now, one thing that we need to know for this saying to make sense and for it to work is that we're assuming that weather is moving from west to east, okay? But in order to get a red sunset, here's what we need to know. Number one, as the sun gets low in the sky. All right, how many of you boys and girls have learned Roy G. Biv, the spectrum of light? Red, orange, yellow, green, blue, indigo, violet. Well, as the sun gets lower in the sky, more light, the light travels through more of the atmosphere. We see the longer wavelengths, which are more the red shades of that visible light. We see more red light as we get later in the day. And so the reds get scattered as they travel through the atmosphere and might eventually be reflected off of some storms off to the east, okay? So if we assume weather is moving west to east, that's telling us the storms are already east of us and moving away from us, meaning that nicer weather is out to our west. That's why sailors believe red skies at night, sailors delight. Another thing that can help give us some of that red shading in the evening is high pressure. When you have high pressure around, that's more conducive to having the atmosphere being a bit drier, having some dust and other particles in it that can also enhance that red color. So that's part of what goes into it too. So red skies at night, sailors delight. The opposite is red skies at morning, sailors take warning. So in the morning, the sun rises in the east. Same story on why we get more kind of orange and red in the morning. There's the light's traveling through more of the atmosphere, more of the red light gets reflected. And so in order to see more of that red light, though, we need it to be reflected off of something. And if we have clouds in the west in the morning as the sun comes up, that might help us give us more of a red sky. And the sailors knew, red skies at morning, sailors take warning. That could be a sign that storms are on the horizon and headed our way. So overall, as we look at this saying, red skies at night, sailors delight. Red skies at morning, sailors take warning. It is mainly true. Hopefully that made a little bit of sense. I know that last one was kind of complicated, but hopefully it makes a little bit of sense. All right, that's all I had for you today. So we talked about rainbows and sundogs and halos and Virga and lots of cool stuff. Hopefully you learned a thing or two. I'm going to hop back into my studio now, and if you have any questions, pop them in the comments on Facebook. Have mom or dad help you out, and I'll be happy to answer whatever questions you might have. All right, boys and girls, hopefully you learned a little bit today about some of the cool things we could see when we just open our eyes, step outside, and look up above us. Those rainbows, the sundogs, the Aurora you see behind me. That's a little bit harder. You got to travel usually to see that, but we talked about Virga and some cool stuff. All right, just peeking over here to Facebook, see if anybody had any questions. I saw Linda posted, I think this was before I got to it, what is a sundog? So we talked about sundogs, kind of that optical illusion that's created when you've got clouds made up of ice crystals that bend the sunlight, and they bend it at a certain angle, 22 degrees, where you get these bright spots on either side of the sun. Those are sundogs. So if you have any other questions, let's see what else we've got here before we wrap it up. I see my friend Derek asking again about visiting the station. Hey, Derek, good to hear from you. So again, as I said here at the end, we're wrapping up Cap's Corner Summer Camp. It's the end of the summer just about. Hate to break the news to you kids. Yeah, so many kids, I know including my two, are back to school next week. So if you missed any of the lessons, you can always check them out. Let me show you on wap.com/Caps Corner. We've got all the lessons posted there. Today's lesson, not quite posted just yet, but when it is later on today, I did put together a couple of worksheets, a word search, and some questions about what we covered today. So be sure to be on the lookout for that. And you can also catch the lessons on YouTube if you want to go watch them on a bigger screen that way. But in the meantime, let me come back on screen. We'll take one more peek at Facebook to see if we have any questions coming in. If not, doesn't look like we do. So we'll go ahead and wrap it up. But hopefully you boys and girls learned a little bit this summer. You can access these lessons at any time. You can access those worksheets on the website as well. So we'll wrap it up. And in the meantime, keep an eye out for Coast and Climate. That's my video podcast doing almost every week. We take a break here and there, but almost every week. Those episodes premiere Thursdays at 10 o'clock. We'll see you then. We'll see you on air as well.